I want to try this on camera, so in case it explodes I still have a video. I want to wire up this DC to DC boost circuit to a USB and power a 12 volt LED strip with it. So I won't be connecting the LED strip directly. First I will just connect it to a USB and measure and adjust the voltage from this potentiometer or trimmer, or I don't know what you call this thing. You twist the screw and the voltage changes. Hopefully when it's in, it's the lowest voltage. We'll see. Anyways, I will just connect a multimeter to it, not the actual LED strip, which could burn if the voltage is too high. So yeah, I will just solder the USB cable to the input. Hopefully. This wire is kinda flaky, brittle. I don't know what it's doing, but it will be good enough for a test. Man, yeah. It totally sucks. It's thin. Nah, but it will do. I'll just cut off the end because it's too long. Like that, and hopefully it will stick for at least for the test. Let me put on. Oh, it has enough solder. So here's the input. The negative input is the blue. Man, my hand is shaking again. Oops, it's not stable. Let me just put it on something. I don't know what. Maybe on this fan. Perfect. So the blue is to the negative. Yeah. Don't tell anyone, but this is a shitty. Oh boy, I recognize this wire. It doesn't want to hold solder. Oh boy, I picked the perfect parts for the test. Nah, now it's better. But yeah, this sucks. This really sucks. Now I got it. But that really sucks. I don't know what's wrong with this wire. It's really bad. I used it before for something else. This was the cable of a USB hub. And it was also poor quality, so yeah. Poor quality product, poor quality wire. Come on! I'll put you in the hole then, if I can. Yeah, now it stays. Okay, now that's a proper soldering job, even though the cable is shit. So the positive is that and the negative is that. So, here comes the funny part. Do sparks fly? Let me check for a short. First, so this, let's hope this is not shorted. No. Okay, it's normal. So let's plug it into this power bank converted from a laptop battery. So I'll just plug it in, measure, and start twisting the knob. Yes? Nothing blew up. Okay. So let's switch to voltage. Oops. Come on. Let me just pretend that I planned things properly. So, yeah, you can barely see the voltage. The positive and negative, like this and this. And it's nothing. What? Let me just twist this thing. This doesn't twist. What? I need a thinner screwdriver. Yep, it doesn't do anything. This is weird. And there's no input voltage either. What? I thought I soldered it properly. It's 1 volt. What? I don't understand. Let me check with a power supply. I mean a phone charger. Where did I put those? The crappy one. Here's a crappy. Let's put it in. And what's the voltage? Am I that stupid? What am I doing here wrong? The input is 5 volts now exactly, and the output is 22. Okay, so there's something wrong with that that power bank. Yeah, that's it. So let me just adjust this. This goes to the left and this stays on the right, because the cable is not long enough. And this is bad position. Come on. What am I doing wrong here? Ah! Everything is connected, moving around. This is not good. Okay, finally. So it's 22. Let's start twisting. So if I pull it out, it increases. Let's twist it back. I need 12. Does it do 12? I don't think it does 12. I really need 12 volts. Yeah. Okay. It does go down. Perfect. Just gently, I will put it to 11.5. Okay. So with 5 volts, 11.5. Now let's try to connect this LED strip. How can I connect it the easiest? Or do I have one with connected wires? Oh, I misplaced them. I misplaced those. Where did I put them? Whatever, I will just solder it on. Maybe. Yeah? Any better suggestions? No? Yeah, I will just solder it to the LED strip and yeah, and hold it with my hand to the output. So let's see. This little module doesn't consume much. It needs about 0.3 watts maybe. Very, very, very little energy. I mean power. So let's solder these on. Yeah, if I plug in the soldering iron, then it works better. Yeah, and let's pull this out for a bit. So yeah, you need power for the soldering iron. Strange. I can just solder this directly, I think. Yeah. No. What am I doing here? Yeah, now it's better. So basically what I'm doing here, any 12-year-old can do with some basic skills. Basically, if you can write, you can do this. Okay, it's on. Let's check the voltage again. I'm not taking any chances, and let's try not to short circuit anything. So the 11.5, okay. And if I connect this, let me just strip the wires. So the positive to the positive and the negative to the negative. And it lights up. So it's that simple. That's interesting. So now let's remove this and solder on the LEDs and try a power bank, because I want to be able to use an LED strip with a power bank. That's the main goal. And maybe even with just the battery, not the whole power bank. I will charge up a lithium-ion battery, and with 4 volts, it will do. Okay, again a shitty job, but it works. And the positive, let's put something under it because I don't want to ruin my table just yet. It's brand new. Okay, worst job ever. So let's see. It turns on. Here are the lights. And let's try the power bank. And then let's measure the voltage, because I measured this power bank and it gives, oh, and it turns off. Oh no, it has a bad plug. So okay, bad soldering. Let me redo that. Let me put something under it and redo this crap. Yeah, it just sticked to the PCB but didn't really melt the solder. When you hear that screeching, that means it's okay. The soldering will be good. Metal on metal screeching. So yeah, let's plug it in. And it works! Perfect, and let's measure the voltage, because now the input voltage is higher, allegedly. Let me show you. So now the input should be 5.1. No, it's exactly 5. Interesting. And the output? Come on. Is exactly 11.5. That's wonderful. So yeah, with this boost circuit they say it supports up to 5 amps. So it could take 5 volts, 4 amps, that's 20 watts. But usually the 5 volt outlets, I mean USB ports on chargers and everything, they can only output maybe 2.1, 2.4. Some of them can do 3, but that's pushing the limit. So yeah, I have about 10 watts to work with here, and that would be about 1 meter of LED strip of the more powerful kind, or 3-4 meters of the weaker kind. I don't think this is the cheapest one I got. This you can light up the whole strip 5 meters with just about 15 watts. So yeah, if I want to use this strip, I can use up to maybe 3-4 meters. That's acceptable. At least 2 meters. Let's say 2. Because we don't want to melt anything. So yeah. This one can only output 1 amp. And usually USB ports do only 1 amp. So I best design for that. Only for 1 amp, 5 watts. That is still a lot of power, still a lot of brightness. In case of emergency, you can use this to light in every direction. Maybe have several locations. Put a power bank with a few pieces of LED strip in each room, and it can light the whole house. I mean, minimal lighting, just to survive an outage. So yeah, this works, and it's surprising how well it regulates the voltage. For $2, I highly recommend this. It's not even heating up with just these 3 LEDs. It's allegedly up to 93% efficient. So maybe with 4 amps it would start heating up slightly, but 1-2 amps, no problem at all. No problem at all.